Hello, computer enthusiasts. Today I want to write a little operating system, or to be more exact, a bootloader, that when you fire up your PC, it shows you which keys you press. This will be super interesting because you will learn some low-level stuff, how the keyboard communicates with the processor, how you write assembler, and how you use assembler, and so on. It's going to be interesting. But first we need an assembler. And I decided for the NetWrite assembler, and now I'm downloading the version for Windows 64 because I want to do this under Windows. And then I go here and I run it, but as administrator. And then I say yes, I want to allow this thing to modify things on my computer, and I say install. Now the next step is to get it running. So again, we click on Windows, say CMD to get a command prompt, and in this command prompt I say NASM, and I find it is not executable right now. Why is it not executable? Because it has been installed to another path. Let's look to which path it has been installed. We look on this PC, operating system, program files, and there we have it, NASM. And now we have to add the path of this executable to our environment. So what do? We run system.cpl, click here, and there we have the possibility to go to advanced environment variables, and then my variables. Yeah, I want to add one path. I want to add C: program files NASM. Is that the right one? Let's look. It is C: program files NASM. What a luck, we don't have to worry about capital letters and small letters. And I say OK, and I say OK, and I say NASM, and it does not work again. So I have to start a new shell in order for the changes to become active. I click here, I say NASM, and we see something happens here. Yeah, we see the program is being found. So congratulations to ourselves. We have installed the NetWrite assembler under Windows. So let's write the bootloader. We say notepad boot.asm. Yes, we want to create this file. And now I paste the code here. I will paste this into the video description as well. And the deciding thing is that we only have 512 bytes to fill with machine language, and all these comments and assembler commands will be condensed to 512 bytes. Otherwise, it wouldn't work, because when the computer starts, it only loads the bootloader and executes it. So usually the bootloader does nothing else but load more sectors. One sector has 512 bytes, load more sectors from the hard disk and execute these as well. But this is not what we want to do here. We just want to do an experiment to better understand assembler and machine language. So what's absolutely notable and what you should look for here is that we set HA, the register HA we set to 0, and 0 means wait for a key, and then we call interrupt 16, hexadecimal 16. So this interrupt will then look at the processor register HA, find, okay, it is 0, so I have to wait for a key. And once the key has been pressed, it will store the key value into the register HA. After saving the file, we need to compile it using the NetWrite assembler. For this, we use the command NASM-F for format, bin like binary, boot.asm for the source file, and -O for the output file. Boot.bin will be our output file. I type enter, and now we have a freshly created file boot.bin, and this file is exactly 512 bytes of size, and it is binary, which means we cannot really read it. So this is not readable, this is gibberish, but this is machine language. So As a contrast, if we have a look at boot.asm, this is something we can read. So we are on the right track. We have a binary file that can be executed, and that is 512 bytes tall. Now I could use this boot sector, put it onto the first sector of my hard disk, destroying all data that I have in my system, boot my computer from this hard disk, and see what scan codes I get. But I have a better idea. Let's use a virtual computer, and for this we use QEMU. And for QEMU, this is a virtualization solution. Let's take the latest version and install it and run it as administrator again. And again, we have to tell our system where to look for the QEMU binary using the command system.cpl. Again, we go to advanced, again, we go to environment settings, and again, we have a look at the Windows administrator to find out where this has been installed, and we find it again under program files, QEMU, and where is it? Let's see. Here is QEMU system everything. So you can emulate every system. You can emulate a Spark system. You can emulate a RISC system. Let's see, you can also emulate an x86-64 system, which is what I want to do. But I'm interested, I can also emulate the 32-bit E386 system, which is great. So again, we use the same. We extend our path, which means the path is where the system is looking for commands. And we say new path, and this time it is C:\program files /QEMU. Okay. And I think again I will not be able to say QEMU dash, and now I type tab, but nothing happens. So I go out and I log in again. So the environment variables will be refreshed. And now I type QEMU and then tabulator key. Does not work. Okay, so let's have a look. It's called QEMU-system-x86. And we have something. We can indeed do something with this command QEMU, which is good. So what do we do next? We tell the system, hey, emulate an x86-64 computer, so a normal computer, and give it a hard disk that only contains of boot.bin. So it only contains of one sector that we have just created, which is the boot sector, and this outputs the scan codes of the keys you press on the keyboard. So, okay, I type enter, and here we see how this all would have looked if I had put if I had put this boot sector directly onto my hard disk of my laptop here. Okay, so I would panic if I saw this on my laptop because it does not start my favorite operating system, Linux, Windows, or whatever, and it starts my self-programmed operating system. So good that we have virtualized this. And the promise is now that it will show the BIOS scan code. So I type hello world. Let's type let's not make it so complicated. Let's just type an H. H has the scan code 23. Okay, 23 in hexadecimal. So I just type hello world now. So every key gets a scan code, and if I type L 2 times, then I see 2 times the same scan code. And now the fun part comes. If I type escape, it just says 01. Because escape is the first key on your keyboard if you number them. Okay, now what do I type next? I type F1, and you can now imagine what the scan code of F1 will be. It will be, of course, 3B hexadecimal, because we are talking about the system that works since 40 years or so. And 40 years ago, we had different keyboards, and the function keys were located on the right. So if you number the keys on this old keyboard, then you will find that the function key F1 starts on the right somewhere else, and it is not adjacent to the escape. So I type escape, F1, F2, F3, F4, and so on. And you see the function keys, they are sorted next to each other, also here with regards to the scan code. Type Shift, and nothing happens, because that does not get a scan code. Similar for all modifiers like Control, Alt, and the key that had not been invented, which is the Windows key. And when I type this, of course, Windows thinks I'm talking with it, and not this thing. Okay, I have to focus on this window before I type the Windows key, and then nothing happens. Okay, and if I focus on another window and type the Windows key, then something happens. Okay, so the difference is if you focus on this window, and I click now here, and that means the mouse cursor belongs to my virtual machine, and I have to press Control Alt G to release the grab, and that used to be written here. Okay, so I type please watch this line here, and now I say, hey, mouse cursor is attached to my virtual machine, and then you see press Control Alt G to release grab, and that is exactly what I do to get my mouse cursor back so I can navigate here in Windows. Yeah. This is what I love about assembler. It really makes it possible to look behind the scenes and to find out how, for example, the keyboard and the processor communicate with each other. Hope you liked it too.